welcome to GDC Classes English. So today we are back with our another video in which we are going to talk about the non-Newtonian systems. In the previous video we have already started with our time dependent systems. Briefly, I am going to show you what we have covered till now, and which we will continuously start with our time dependent systems as well. Okay, so the highlight of the video is actually the time dependent system, in which we will cover the thixotropy and 𝙂𝙀𝙎𝙀 phenomena. Okay. And before we even begin, I would like to inform you all that these videos, these sessions we are conducting here, these are highly important, not only from the GPAT point of view, but you take example of any pharma related competitive exam. We have taken like literal notes of the important topics which are continuously asked in the exam. So the session series is framed in a way that it is important. So do not miss it. Do not miss a chance to learn from all the expert faculties out here, and make sure that you add your own feedback in the comment section. We actually go through each of your comments, take your feedbacks very seriously and work on it, right? So it is very important for us to know what you think of the video and what you expect out of another topics that you want. Okay, so this is my personal request. I always ask for the feedbacks and I am looking forward to it. Okay, so now without wasting any time, let's start with our topic, which will be non-Newtonian systems. Okay, in the non-Newtonian or Newtonian systems, we have already seen that Newtonian systems definitely follow a Newtonian's law of fluids, which means the rate of shear and shearing stress are directly proportional, and the same is not followed by the non-Newtonian systems. In the non-Newtonian systems, the particle behavior usually changes with the change in the rate of shear. Okay. So next important thing to note down here was how we categorize this flow of fluid into Newtonian and non-Newtonian. In the non-Newtonian, we have seen time independent plastic system, pseudoplastic and dilatant system, and today we will focus on the time dependent system, thixotropy and anti-thixotropy. Now this is my experience that is saying you always get one or two questions from this only topic from the rheology part also, right? So make sure to listen very carefully. So in the last class, what we have covered, we have summarized this way. So plastic systems are the systems which need additional yield value to be actually able to flow, right? You can already see the material here. We do not start from the origin. They need additional yield value to be actually able to flow, right? You need the material to be able to push, and then they remove their aggregates, the floccules, and then they are able to actually show their flow property. In the pseudoplastic ones, here no yield value is required. As you apply the stress, the material easily begins to flow. Third, in the dilatant system, here once you apply the stress, the material actually expands or dilates, right? From the name you can see dilatant flow. So the material is actually able to dilate. That is why the pseudoplastic ones are known as shear thinning system. The dilated ones are known as shear thickening systems because of their ability to dilate or expand, right? So in this case of the plastic systems, we say these are known as Bingham bodies. All these 3 points are very important. Next, in the case of the plastic systems, the example here is basically the flocculated suspensions, because you must be able to remove these floccules, only then they will be able to flow, right? So we have the flocculated suspensions here which need an additional yield value, okay, and then afterwards the viscosity increases once you increase the rate of the shear. Then in the pseudoplastic one, where it is shear thinning system mainly includes all the gums, natural tragagons, sodium alginate. Once you apply the stress in the form of, let's suppose, heating, so it will start to lose its attractive forces and is able to flow. That means the viscosity is going to reduce down. Okay, that's how we say that the viscosity generally reduces in the shear thinning system which is justified by its name also. Now it's shear thinning. That means the viscosity is reducing. Okay. Then we have shear thickening system. Name suggests thicken. That means expand, dilate in the volume. If you increase the concentration, that means you make a deflocculated suspension. It includes a deflocculation here. That is the dilated system, where also the viscosity will increase. Okay. Now, we have time independent systems to talk about. These time independent systems also deal with the change in the viscosity. But once you remove the stress, what happens? Let's see with an example. Suppose we have a simple example of gel to sol to gel conversion. Gel to sol to gel conversion. Initially, because it is a gel state, it is most evident that viscosity of gel state is quite higher as compared to the solution state, right? This eta is none other than our viscosity parameter. So if you have up to apply the stress, it converts the gel state, which is a higher viscosity state, to a sol state, which is a state of lesser viscosity. And now once you remove the stress, it again switches back to its original state. So we can say in the time dependent system, we usually get an isothermal and reversible phenomena. That means again it changes back to its original state, initially gel to sol to gel state. Now this does not happen that easily that we think. Generally, once you remove the stress, it goes back to the original state, but this happens at a very slow pace. This happens very slowly. You have to keep it standing for good extended hours, right? So gel to sol to gel conversion is there, but you have to let it go very slowly, it converts. So this phenomena is known as thixotropy, where the original rebuilding of structure is taking place. Rebuilding of structure, isothermal, reversible, and third line should be rebuilding of structure. Correct? Now we get back the gel state slowly. That will be termed as thixotropy. But if you can convert this at a faster pace, if you remove the stress and you want it to convert into the gel state but at a faster pace, how can you do that? By adding any additional agitation. Listen to me carefully. By adding any additional agitation or vibration or any turbulence that will convert this, that will actually increase the speed of conversion back to its original state. This will now be termed as 𝙂𝙀𝙀𝙎. This now here will be termed as 𝙂𝙀𝙀𝙎. So thixotropy is nothing but gel to sol to gel conversion upon removal of the stress, but you have to see that this is a slow conversion. That means the rebuilding of structure is quite slow and then it is converted into the gel state again. Okay, so you have thixotropy here. Then if you want to convert it fastly, you need to apply any additional force. Simply gentle agitation, gentle stirring, gentle vibration or turbulence that can convert this into much faster pace. Then you get the 𝙂𝙀𝙀𝙎. So now somebody asks you what is 𝙂𝙀𝙀𝙎 or thixotropy. It is a gel sol gel conversion in which you have to see the rebuilding of structure back to its original state, but it occurs at a slow pace. That is a thixotropy. Once you apply any additional force, agitation or vibration, it will be converted fastly and you get the 𝙭𝙎𝘋𝑐. Okay, clear? Similarly, we have two more systems. We have two more systems. We have negative thixotropy and negative 𝙭𝙎𝘋𝑐. Now let's take example of sol to gel to sol conversion. Similar to the previous one, firstly you apply stress to the sol state which has low viscosity. That means it will expand or it will increase in the viscosity upon applying the stress. Now you remove the viscosity, now you remove the stress, it will come back to its original state of sol. Right? This will be termed as negative thixotropy. Why? Because this process is also taking place very slowly. Right? So this will be termed as negative thixotropy. Thixotropy was gel sol, gel slowly converting, rebuilding of structure. Antithixotropy is Antithixotropy is sol gel sol, which is also occurring slowly, but it is slow sol gel sol conversion. Thixotropy is gel sol gel conversion. Next, same process, you can start sol, apply stress, convert to gel state, remove the stress, it converts to sol state, right? But you can convert it into sol state at a much faster rate. How? By applying any additional vibration, any gentle stirring or shaking, which will convert it into gel sol state quite faster. Now this will be termed as negative 𝙭𝙎𝘋𝑐. Okay, so we have four phenomena that we have seen: thixotropy, 𝙭𝙎𝘋𝑐, negative thixotropy and negative 𝙭𝙎𝘋𝑐, right? So this is the important topic that we had to cover today. So just to summarize it, thixotropy is gel sol gel slow conversion. Then we have gel sol gel fast conversion 𝙭𝙎𝘋𝑐. Then we have sol gel sol conversion antithixotropy. Then we have sol gel sol conversion fastly, that is negative 𝙭𝙎𝘋𝑐. So that's it for today. I hope you have understood the topic and we will meet in the next session very like almost in regularly you are seeing the videos. So this is a generous request from our end to kindly take the notes of the videos. Try to study as dedicatedly as you can. Okay. Thank you so much. All the best.